Howdy everybody in YouTube land. This is part 2 of our little monitor adventures. So if you remember, part 1 was back in April where I plugged this monitor in the wall and it had vertical distortions on the screen. Then I let it run shortly after I concluded the video and then it blew up. It just completely failed and it screams really loudly. So, what we're going to do here is find out what the hell happened. Now, just to show you that I'm not kidding, I'll plug this thing in down here in the power strip of doom somewhere. Alright, now, not kidding. So, usually a sound like that means there's a dead short somewhere in the vicinity of the power supply unit. So let's go over this real quickly here. Put that on. Let's use this crappy Radio Shack flashlight. This right here is the part that most people get scared about monitors, but I don't care. It doesn't bother me at all. Only because I'm not afraid of shit, but that's just me. And I've worked on these things so many times that I have respect for them. But that's not the point of this video. The point of this video is to figure out what the hell went wrong. So, what we have here is the analog horizontal output stage, filters, and, because this is not multi-sync, everything is narrowband, so everything has to be tuned exactly to the scan frequency you're using. So if you decide to increase the scan rate of this monitor, you would have to retune the horizontal output stage. But basically, let's see, I got a tripod now. This might be a little bit noisy. Here we have the flyback transformer, which is, otherwise known as the line output transformer, connected to the anode cap. And then right down there is our little vertical output chip. That was our point of failure until now. What we need to do now is inspect around the area and make sure that no resistors had failed, or any burnt solder joints or anything like that. And you could just see it hiding down there, that little dip package. That's the sync generator, drive generator circuit. I was going to say sync processor, but it's not a processor at all. And then there's the video amplifier board right here. And the monitor cable comes right in and plugs just to the left of the video amplifier chip or drive chip. And the thing is I've got red, green, blue in sync, but I don't have any monitor sense wires, so that tells me that the monitor sense wires are actually in the end cap of the DB15 connector. That cable's bad anyway, so once I get this monitor working, if I get this monitor working, I will be replacing that cable with a repaired cable or a good cable, which is this guy right here. Actually, no, it's this guy right here. There's a bad spot in this cable because if you remember in the video, the green was going in and out, so you'd have to wiggle this cable to get it in. So this cable's junk anyway. But there's 3 monitor sense wires in the old Macintosh standard, and they're hardwired inside this hood, molded hood, so you can't get to them. But I got a generic pass-through cable, so I'm going to replace this cable with a new one. And so I'm just going to tie the wires off back in here. Now I'm going to modify this thing so it'll run 640 by 480 because these original monitors were only designed to run 512 by 384, and a lot of earlier Macintosh games required the 640 by 480 format. And the reason why this is 512 by 384 is because these were designed and made up with the Macintosh LC, and the original LC series was limited on video RAM. So to get the maximum number of colors possible, they lowered the resolution because it was the LC, low cost. So that's why they did that. Now, this monitor, if you haven't been able to tell already, is made by a company called Matsushita, otherwise known as Panasonic or Technics. or any of those other familiar names. Apple just stuck their name on it, but it was designed and manufactured by Matsushita, Mitsubishi, whatever you want to call it, because it's the same symbol. And here's even more evidence of that right here on the back of the board. You can almost see that. Now you can. Yeah, there's the part number of the board, and then I actually put it into the copper on the solder. Alright, so the cool thing is the light washes out the camera, so I'm just going to offset it a little bit. Maybe move this a little bit closer. The flyback line output transformer, the connections, or what they are labeled. So that's kind of cool. So it makes it a lot easier service because we don't have a schematic for this thing. I'm sure there's a service manual online somewhere, but I don't know where it is. We have our controls on the top here. We've got our horizontal centering, vertical centering, height, vertical linearity, horizontal hold, phase, which is another term for linearity, and then vertical hold, which means this processor, or this deflection drive chip, is analog, which we pretty much knew that. So what we're going to do is take our meter and figure out where our failure mode is. So sorry for the lighting, but I can't hold the light and use the meter at the same time. So we're going to take our crappy Radio Shack meter, and the first thing we're going to check here is we're going to check this guy right here, which is the horizontal output transistor. And how you could tell that that's the transistor is because you could see this big fat trace going right into the collector of the flyback transformer. This drives the flyback transformer, and it also drives the yoke. This is the yoke connector that's on the bell of the picture tube. Now, this shorts out. It's going to load down the 100-volt supply coming right off the switching power supply. And the switching power supply is fairly simple and straightforward. There's a 5-pin regulator here, which I can just about bet you that is an STR-based integrated circuit, because the cheaper switch mode power supplies from the 80s and 90s, they had a real surplus, or a real habit, I should say, of using those chips. Instead of using a discrete transistor and a SMPS chip and all these discrete parts, they just integrated into a single STR, which I can just about guarantee you is not manufactured anymore. However, this guy is still good because we're getting a loud buzz, which means this thing is trying to start up, but there's a heavy load somewhere on the secondary side of the transformer. Now, luckily, there's some test points here. We got 70 volt, we've got 24 volt, we've got 100 volt. So if you're not me and you don't realize what's going on, the first thing you want to do is you want to check. Let's see. Let's put this in continuity so you can hear the beep. So, first thing we want to do is we want to check across the main output filter cap. Well, looks like we got a short. So we'll ground this lead here to the chassis, and then we'll check our 100 volt test point right here. Okay, we're shorted. So since we know that we have a short at our 24 or 100 volt test point, something serious has happened. So yeah, that's pretty bad. Now, the secondary diode could be bad. There's always that. But most likely, I mean, it's possible it could be bad. I mean, you can't rule that out. And if you're not entirely sure, you can always remove one leg out of the board and test it external to the main board. Just lift it up and put your leads on the other side. But I don't think that's our problem. So since this is our 100 volt supply, that 100 volt supply, let's test our 24 volt. 24 volt's good. Let's check our 70 volt. There's no shorts there. The short is purely on our 24 volt supply. And actually, here is a fuse. There's actually a small little secondary fuse here. And it's good. But that's not for our 100 volt supply. Our 100 volt supply is going all the way, let's see if we can follow this guy. 100 volt supply is going through the inductor all the way over to the flyback transformer into our transistor. So there's our B plus supply, shorted. collector shorted, so the flyback has still got continuity across it. Okay, so that's toast. Okay, all right. Now there's the horizontal output transistor, which you can usually tell because it's connected to the flyback and it's the biggest transistors connected to it. So short, short. Yep, it's shorted all the way around. That went bad. Now, what could have caused our horizontal output transistor to fail? Well, there are several causes for that. The line output transformer could have went bad, or more likely than none, since we did see the symptoms of the screen prior to the failure, prior to the permanent shutdown of the monitor, is we saw the vertical distortion, which means the vertical circuit. Now, the vertical output chip is IC401, which is right here. It's a small little TA83 something another output transistor or transistor chip. The ramp generator may be internal, it may be generated from here. It's hard to say. Now, let's just move the light off the screen so you can see it better without washing it out. So there's our deflection processor, which that's what I want to refer to it, even though that's not what it is, but that's what its primary purpose is. And then there's the vertical output. Now, on the flyback, we have our heater connections. We've got our B+, then we have our X-ray protection. And what that's designed to do is if the high voltage starts to run away, it'll shut it down to stop the CRT from overvolting and creating X-rays. And then we have our 12-volt output here. Now, this is an automatic blanking connection, which looks like the solder joints have seen better days on this thing by far, but we'll worry about that in a minute. There's our feedback off the flyback to get our back porch, what's called the back porch pulse return off the flyback that goes to our video amplifier. Because if you follow it, it goes up and back into here, which goes back to our video amp. And you know, and it's possible that this is the feedback, but this is also the V supply that runs our video amplifier boards too, because the CRT needs a couple hundred volts on the cathodes and the grids, and you got the cutoff voltage and etc, 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 which is not the scope of this video. But then there's also 12 volts here. All right, well, let's meter 12 volts to ground. Okay, we've got a short, but that doesn't mean anything because this is ground and this is 12 volts and this coil is connected together. So we're reading through the coil. So now we need to follow this 12 volts. Which 12 volts is likely the scan supply. Let's follow it down. There's a resistor here and a diode. Now, let's read the secondary output of the diode to ground. Okay, we don't have a short, but let's figure out what our actual reading is. So we'll put it there. Let's meter it. Let's see. I don't know if you can see the meter in that one. Nope, you cannot. But if I scoot it back, you might be able to. Nope, you can't. But I'll read it off. So we're going to meter that point right here on the rectifier diode of the 12 volt supply. And we are reading 0.185 to ground. 0.188, which is kind of low. Let's see what that resistance is. So let's read that. That resistance is roughly 300 and get on there. You stupid probe. I hate you. Oh, 376, 380 ohms to ground on 12 volts. That's a little low. Something has failed catastrophically. So either this diode is bad, which it could very well be. This diode could be bad, or upstream from that diode, the vertical output chip could have failed, which put an extreme load on this diode, which blew the horizontal output transistor. Now, the thing is, this diode, let's see if I can follow this guy. It goes up, over, there's another, 12 volts goes to the video amp, but at the same time it goes over to that's not right. Let's follow this again. Without a schematic, it's really hard to tell what's going on. Okay, we got a resistor here. Let's read across this resistor. 12K. So that's not what our issue is. That's a 12K resistor. So let's keep going up. We've got, it's going straight to the video amplifier circuit. Okay, so that's not it. Then again, it's possible that that does not go to our, it's going to our ABL as well. So, something to think about here. I don't know this design, but with enough figuring out, I'm sure I can get to that point. But since I've got 12K here, and 12.23K, I could pretty much conclude that's not our problem. So we've got a 12 volt supply going here, right to our video amp, which is strange enough. But let's see, it comes down. It also goes over to here. But if I meter the other side of this 5.5K, so I know the short's not there. There's something going on elsewhere. Let's see, resistor. Ooh, there's a resistor here off the yoke. 32 ohms. You know what? That might be normal. That low impedance could be normal because we've got a resistor connected to 12 volts over to in the horizontal section here, which is over through the yoke. So it's possible that low impedance is normal. It doesn't seem like it would be, but it very well could be. Plus, the resistor isn't burned open, and usually when they fail, that circuit fails, the resistor burns open. So we look further ahead. We've got a vertical output chip. Let's follow the V supply and see where it goes. Nope, that's an output pin. That's ground output. This is the feedback off of, there's a weird connection. So let's see. Nope. Check here. See if the VCC circuit failed. No. Let's figure out where that VCC is going, and that's going to be a finesse. See, that's the drive signal, and this is that's a capacitor. What is that? Shorted, whatever that is. It's because it's jumped to ground. That leaves this guy here. It's a capacitor. But what is this guy here? So we've got a V supply. So the horizontal output failure may not be related. That is strange. Why would the horizontal output circuit fail? Something is definitely not right. I mean, chances are, since this thing is old, it's probably capacitor related. I mean, it's damn near determined to be. But well, let me think here. Let's see, I need to follow that lead because it goes over to this connection here, which I'm not sure what that jumper's for. But there's also a resistor that runs over. That might be a V supply here. Yeah, you know what? It is. Let's follow that down. 24 volt. Yep. The 24 volt. That's it. 24 volt comes up, around, and then comes back to our vertical output and our vertical driver. So, yep, that's our 24 volt. But that shouldn't have caused the horizontal output to fail. That's, man, we've got two unrelated problems here. Flyback could have been bad, but you know what though? There's a lot of cracked solder joints on that flyback transformer. That'll cause anything to fail. The horizontal output fail could fail for several reasons. We've got bad solder joints here and here. We've got, you know, there's some bad, really bad joints. Horizontal drive, wow, that's really bad. Holy crap. Those are bad, bad, bad. Yeah, because that right there would cause a system failure as well. Any of this, there's a horizontal width. You know, there's some safety caps, filter caps, and stuff like that that keeps the high voltage down. That could be bad. There could be multitude of things defective. So really, the only thing I can do now is start checking electrolytic capacitors to see if any of them are leaking or bad, because I know there's something wrong in the vertical circuit. Either the vertical amplifier itself is bad, or a capacitor related to that is defective. Now, what I'm going to do is I'm going to pull the data sheets up on these two chips if they're still available, and then I will piece the system together by just following the data sheets. And that's a good thing you can do, rule of thumb, in any electronic product you're working on, is if you don't have a schematic for it, then the best thing you can do is see if you can't pull data sheets up off the chips. Because if you can at least do that, you've got a damn good starting point. Oh, there's the thermistor for the degaussing circuit, and it is pretty cracked joints too. So the solder joints are going to have to be gone through, and then the capacitors are going to have to be checked, and especially these guys here. These resistors are part of the horizontal drive. If these are intermittent, yeah, you're going to blow the transistor every time. So we're going to have to go through and check everything. But before I can do that, I have to pull this board out. So I guess for now, that concludes this video, or at least this part of it, and I'll be back in a second. There's one more thing that I want to do before we completely conclude this video. What we're going to do is we're going to take a closer look at this board. I pulled the data sheets up on the chips, okay? This deflection processor chip, that generates the vertical ramp for the output. So if the vertical was completely distorted, it could have been this chip or an associated component with it. And this chip also shares the horizontal drive, which makes sense because if something is wrong in this chip and it's creating a distortion, it can also cause a spike or distortions in the horizontal drive. And guess what? Pow! There goes the output transistor. Because if there's something, if the drive signal is not exactly right, it can blow the horizontal output transistor. Which chances are that's likely what happened. But just to be on the safe side, the next thing we're going to do is grab our handy dandy little ring tester, and we are going to test the flyback transformer just to make sure that it's not bad. The first thing that has to happen though is the horizontal output. Whoa, that would be bad. The horizontal output transistor has to be disconnected, and that's this guy right here. So we pretty much know it's bad, but let's just cut it out anyway. So we're going to cut that guy out of there. And that transistor is a, let's see, 2SD 2095. Looks like from Toshiba. Let's check and make positively sure that it is bad. Whoa, okay. Alright, let's double check to see if it's bad. Yep, it is dead. So we know for a fact that's dead. So that means the short should be relieved from here now. Yep, it is. That one should still read shorted. Yep, because I'm reading through the drive transformer. Now, alright, so now that that has been done, let's turn on our big blue ring tester. And let's check the flyback transformer. So what we're going to do is we're going to check the primary. Okay, good. The flyback transformer is good. Wow, I can't check for high voltage breakdown, but I can check to see if there's any shorted windings, and there's not. So we can proceed further. First thing I want to do, most likely, is obviously I have to source a replacement, which is going to be a little bit harder than it looks because most of these parts have been discontinued for years. The other thing is the parts for the vertical output stage. That is a TA8403K, and then that is an LA7824. I can get them on eBay, but I have no idea if they're new or not, if they're used pools. I can still get those chips, processor chips, new old stock, but those, I can get an NTE replacement, but I don't know if it's any good or not. Or if it's just generic. Now, like I said, this board, somewhere I'm going to have to figure out where the cause of failure is, because somewhere in this circuit the system is not generating the waveform correctly for the vertical. So could be this electrolytic, could be another one over here. There's only 3 electrolytics in this whole thing, except for the yoke circuit over there, so one can be bad over there and I have to check it. But more likely than not, I mean, it could be one of these purple film caps or maroon film caps that could be bad. But here again, I'm shooting in the dark. But I do have to check that tantalum. There's a little orange tantalum right here. That is part of the vertical circuit. So I have to test that for shorts, test everything else for shorts, leakages, or off value. But chances are this processor is bad. This deflection generator is bad. Because if that generator is bad, it will cause the vertical to go distorted like it is. And it can cause jitters and noise in the horizontal, which blew the output transistor. So I think what I'm going to do is replace that chip, and then replace the other one for good measure, and then check the surrounding components and make positively sure there's no other faults. And that should fix this thing good. If not, I can cheat, because I bought that one supposedly new old stock on eBay, but I don't want to use the parts off of this one. I'd rather just fix that one over there, but just in case I have another one. However, this was sold in the box, Apple service part, new, but it's not. This thing is used as used can be. It looks like it's more used than my original one, which doesn't surprise me, because chances are in the day when this was new, they ordered the part to fix the monitor and then they put the old part back in the box. That was so common. So the chances are this one's no good either. And you can tell it's used. You can see the brown in the circuit board right there where those 2 resistors are. So, yeah. And it says right there, new, unused on eBay. So I could have sent it back and bitched, but I did leave the guy a negative feedback for selling not as described. But I didn't send it back because I can still use the flyback transformer, and I did check it, and it ring checks good. So I have a flyback here, a spare, just in case I need it, or any other parts just in case I need it, because I have another one of these monitors that the focus drifts, which is a bad flyback. So I may need that in there. Anyway, thank you for watching. There will be a part 3 when I get the parts to fix this. So if you have a comment, feel free to leave one. Until next